Federal Pacific electric panels were installed in millions of American homes between 1950 and 1980, and if your house was built during that window, there's a ticking time bomb behind your electrical panel door. FPE breakers don't trip when there's a short circuit or an overload. Electricity surges through circuits without protection. The wiring overheats, the insulation melts, and fires start in homes where people think they're protected. Electricians have warned about this for decades. Insurance companies have stopped insuring homes with FPE panels until they're replaced. A Federal Pacific panel is easy to identify. Look for red-handled breakers and the word stab lock printed on the circuits. The red handles face outward when on, inward when off. That's different from every modern panel design, and that's where the problem lives. The stab lock connection method causes failures over time. FPE settled a class action lawsuit in 2002 over defects that led to fires, proving what electricians had been saying. These panels don't protect homes. They put them at risk. One electrician in Florida walked into a house where an FPE panel was running circuits for the kitchen and master bedroom. The owner had no idea the breakers weren't trip-rated properly. That homeowner wasn't paying attention because nobody tells you to pay attention. The builder's LLC dissolved years earlier. The previous owner never mentioned it. If something goes wrong with those circuits, you're not protected by a functioning breaker. You're protected by luck. Zinsco panels represent a different kind of problem. These were popular, which means plenty are still installed across the country. The failure mode is invisible and worse because of it. Zinsco breakers can fuse to the internal bus bar. Once fused, the breaker never trips. The circuit stays live even during a short or overload. Wires overheat. Insulation melts. Fire risk climbs. The panels are sometimes sold under the GTE Sylvania brand name, meaning homeowners might not realize they own a Zinsco. The rebranding happened decades ago, and many never traced the name back. Zinsco panels were designed for older electrical loads. A modern home with a microwave, dishwasher, 2 AC units, electric water heater, and modern appliances creates demand. These panels can't handle. The panels degrade faster. The breakers fuse faster. One electrician in Georgia pulled a Zinsco panel that had breakers literally fused to the bus bar. When he showed the homeowner the melted connections, she asked why nobody had ever told her to replace it. He said because that house had been flipped 3 times in the last decade. Nobody stuck around long enough to care. The panel kept lights on during inspection. That was good enough for everyone except the people living there when it failed. Challenger panels from the 1980s and 1990s installed in hundreds of thousands of homes carry a specific manufacturing defect. Between February and April of 1988, Challenger produced 15 and 20 ampere breakers with a mechanical defect. A part inside would detach, preventing the breaker from functioning. About 9,000 of these devices were never located. Most are probably installed in houses now. The older Challenger panels, especially before the 2000s, have another problem: backstabbed wiring. This is where wires push directly into the breaker without using a screw terminal. It's faster to install, but creates loose connections. The wires shift. The connections degrade. Overheating happens at connection points. When Challenger went out of business, Eaton and Cutler Hammer purchased the remaining product lines. This means some panels you think are something else might actually be Challenger in disguise. An electrician sees a different name and has to dig into manufacturing details to know if he's looking at a defective Challenger product or something safe. Replacement breakers for Challenger panels can be unreliable, so professionals recommend replacing the entire panel instead of piecing it together. One viewer spent $4,000 to replace a panel because replacing individual breakers kept introducing new problems. That's the cost of a defective design that should never have been distributed. Sylvania panels, especially with stab lock breakers, are notorious for faulty connections. Breakers don't trip during overloads, they fail silently. The problem mirrors Zinsco because many Sylvania panels are Zinsco panels with a different name stamped on the outside. The design flaws are identical. The fire risk is identical. The insurance problems are identical. Homeowners with Sylvania panels are living with Zinsco's engineering inside a Sylvania casing. The panels were commonly installed through the 1960s and 1970s. Some are still running circuits in homes built during that era. If you see the name Zinsco anywhere on your electrical panel, it should be replaced immediately. If you have Sylvania panels with stab lock breakers, get an electrician to verify whether they're actually rebranded Zinsco. If they are, replacement is mandatory, not optional, not something to think about, mandatory. One homeowner in Tennessee discovered her Sylvania panel was actually a Zinsco after hiring an independent inspector for a refinancing. The inspector flagged it. The insurance company flagged it. The lender flagged it. Suddenly, the refinancing couldn't happen until she replaced the panel. She spent $3,500 to replace it. She wished she'd known 15 years earlier when she bought the house and could have negotiated the replacement cost into the purchase price. Instead, it became a surprise expense that almost derailed a life event. Pushmatic panels use rectangular buttons instead of switches that flip left and right. The company went out of business. Finding replacement breakers is nearly impossible, and when you do find them, they cost 4 times what a standard breaker costs. A common 20-amp breaker for a modern panel costs about $7 wholesale. The same breaker for a Pushmatic panel costs $28. The price difference reflects scarcity and obsolescence. When Pushmatic breakers malfunction, they cannot be reset. The breaker stays tripped. If that happens to be the main breaker, the entire house is without electricity until an electrician replaces the panel. There's no middle ground here, no workaround. The house goes dark. One electrician in Colorado described getting called to a house at 2 a.m. because the main Pushmatic breaker had failed. The homeowner thought it was a short circuit. The electrician pulled the panel, identified the main breaker as defective, and told the homeowner they either needed to install a temporary generator and call him back during business hours for the replacement, or call an emergency electrician at 3 times the rate. That homeowner had never heard of Pushmatic panels before. She had no idea her panel was obsolete. The previous owner never mentioned it. The home inspector never flagged it. The electrician kept the lights on temporarily, collected his emergency fee, and scheduled the panel replacement for the next morn. If you have a Pushmatic panel and the main breaker fails, you're not getting GFCI breakers or AFCI breakers. You're not upgrading the panel with new safety devices. You're replacing the entire thing because parts for new safety devices don't exist. The bottom line is this: if you plan on upgrading your home or adding circuits or modernizing your electrical system, you can't do it with a Pushmatic panel. If you're comfortable not upgrading and just hoping the main breaker doesn't fail, you can leave it for now. But understand the risk. The main breaker will fail eventually. Beyond the panels themselves, electricians have noticed a pattern in the quality of residential electrical products sold through big box retailers. Leviton GFCs have caused problems. The connections corrode. The reset mechanisms wear out faster than they should. Electricians are switching to P&S outlets because they just work. They don't have the failure modes that Leviton receptacles developed. The WR receptacles from Leviton have a specific problem. The screw that tightens the pressure plate for the hot and neutral conductors likes to twist off. When that happens, the connections loosen during normal use. Your outlet stops working reliably. Your appliances don't get consistent power. Almost anything IEC standard is subpar, according to electricians who see the failures. IEC equipment is designed to be built to the minimum specification that passes testing. NEMA equipment was designed to be bulletproof and repairable. The difference in engineering philosophy is visible in the failure rates. The ceiling fans from Home Depot and Lowe's accumulate complaints from electricians who install them. The wiring is thin. The connections are weak. The motors fail early. You can buy a fixture, install it, and watch it fail within a few years. The electricians don't recommend those products. They recommend going to a professional supply house and buying from brands that are designed for longevity, not minimum code. The problem with buying electrical products from retailers is the same problem with buying plumbing fixtures from retailers. The manufacturers know these products will be purchased by people who don't understand electrical systems. So they minimize the engineering. They minimize the durability. They maximize the margin. The product passes inspection. The product gets installed. And 5 years later, you're paying an electrician to fix something that should have lasted 20. If you have any of these panels, get an inspection. If you have any of these products installed in your home, schedule replacement. Don't wait for the failure. Don't wait for the fire. Don't wait for the insurance company to deny coverage because you let the risk compound. The electricians in the comments know this. The professionals who see these failures every week know this. The homeowners who've had fires or insurance complications know this. If your panel was built between 1950 and 2000, assume there's a problem. Call an electrician and verify. That call cost you $100 to $200. The fire you prevent might save your life. Subscribe, because next week we're covering the one type of electrical panel that actually lasts. And it's not what builders installed in your house.